Hello grade 9 students, welcome back. This is video lesson number 8 and I'm Madhu Vadke. Today we will start with a brand new chapter number 2, polynomials. In today's class, we will understand the meaning of constants, variables and coefficients in an algebraic expression. We will define a polynomial and its degree. By the end of this lesson, we will be able to identify and write different types of polynomials based on the number of terms and degree. So let's get started by recalling what we already know. We will begin by recalling what we have learned about algebraic expressions in our lower classes. An expression that is formed from any combination of variables and constants by using some or all of the operations like addition, subtraction, multiplication, division are called as algebraic expressions. Here are some examples like x 3x minus 2y plus 7 or pi r square minus half x plus 1. All these are algebraic expressions that contain constant multiplied to a variable. Now, what is a variable? A variable is denoted by a symbol, that is alphabet, that can take any values. Those values can be real numbers, whereas a constant will always have a fixed value. For example, 5 is an algebraic expression which has no variable part and is called as a constant. Example, area of a circle is given by pi r square. Here pi is a constant number which will not change, but r is a variable. So depending on the radius of the circle, the area can vary. Now 3x minus 2y plus 7. This is an algebraic expression. Even x is an algebraic expression which has one variable. An algebraic expression has parts that is separated by minus and plus. These parts are called as terms. So 3x is a term, minus 2y is the second term, and 7 is the third term of this expression. In this example, 3x minus x square and 1 are called as the terms. Notice that these terms are connected by plus and minus in an expression. Now this expression has 3 terms. But an expression like 2y minus 1 has 2 terms. The expression pi r square has just 1 term. Now each term of the polynomial has a coefficient. So what is coefficient? Coefficient here is the numerical part attached with the variable. So in the first example, coefficient of x will be 3. Coefficient of x square is -1. Similarly, in the second example, coefficient of y is 2. In today's class, we will study about a particular type of algebraic expression called as polynomial. Let's consider some examples. 5x square plus root 2x minus 1 minus 2 upon 3 y root 5 upon 2 x to the power 3 minus 1. All these are examples of a polynomial. Notice the power of the variable in each term of these expressions. The powers are whole numbers. So, for an expression to be a polynomial, the power of the variable should be a whole number. Consider some other examples like root x plus 3, 1 over x square minus 1, 1 by x minus x. Are all these also polynomials? No. These are not the examples of polynomials. Why? Because the power of x in the first expression is half. Root x can be written as x to the power half, which is not a whole number. Similarly, in the second expression, the power of x in the first term will be minus 2 when x square is written as numerator. Minus 2 is not a whole number. Likewise, in the third expression, the power of x in the first term is minus 1. So, in these three examples, the power of the variable is not whole number, and that is why they are not polynomials. Now, if the polynomial is in x, like x plus 1, then we write this polynomial as p of x. X inside the bracket. P of x means polynomial in x. If we have a polynomial in y, we can write q of y equal to y square minus 1. So, this is a polynomial in y. Another polynomial r of x can be written as x square minus x cube plus 1. So, this is how we write polynomials in the given variable. The variable inside the bracket means that the polynomial is in this variable. Now, we are considering examples where there is only one variable. However, a polynomial can have more than one variable. For example, x cube minus xy plus y square is also a polynomial, but this polynomial is in two variables. Now look at these examples. 2x or 5y minus 2 z cube t to the power 100. All these are polynomials because the variable has a power which is whole number. But all these polynomials have just one term. Such polynomials are called as monomials. So polynomials having just one term are called as monomials. We have also written earlier some examples that have two terms like x plus 1, x square minus x. These are examples of polynomials with two terms. X is one term and plus 1 is the other term. So polynomials containing two terms are called as binomials. Similarly, if there are three terms like root 2 plus x minus x cube, there are three terms in this polynomial, then the polynomial is called as trinomial. So three different types of polynomials based on the number of terms it has. Now in these examples of binomial, observe the power of x. In the first polynomial, the power of x is 1. Whereas in second expression, power of x in first term is 2 and in second term is 1. So the highest power in the first polynomial is 1, whereas the highest power of the variable in the second polynomial here is 2. The highest power of variable in a polynomial is called as degree of the polynomial. So the degree of x plus 1 is 1, whereas degree of x square minus x is 2. Can you find the degree of this polynomial root 2 plus x minus x cube? The highest power is 3. Therefore, the degree of this polynomial is 3. Based on the degree of the polynomial, we can divide polynomials into different types. X plus 1 has degree 1. Then this polynomial will be called as linear polynomial. X square, y square minus 1. These are examples of polynomial with degree 2. Then this polynomial is called as quadratic. Minus 5 t cube minus x cube minus 3. These are examples of polynomials which have degree 3. So such polynomials are called as cubic polynomials. Can you guess the maximum number of terms a linear, quadratic or cubic polynomial can have? Let's write down the general form for different polynomials that we have studied. A polynomial with degree 1 is a linear polynomial. Its general form will be ax plus b. The power of x term is 1, that is the highest power, and there is a constant, provided a is not equal to 0, because if a is equal to 0, then this term is only left with constant and the degree becomes 0. Examples of linear polynomial: 4x u minus 1, 3 upon 4 y. All these are linear polynomials. The maximum number of terms a linear polynomial can have is 2. It can have one term and maximum 2. Now the general form for quadratic will be ax square plus bx plus c. Again, a cannot be 0. which is the coefficient of x square. If the coefficient of x square is 0, then the x square term becomes 0, and then the polynomial becomes a linear polynomial. Examples: x square minus 1, 4x minus x square plus 1, or 3 on 4 y square. All these expressions have highest power 2, so they are quadratic, but you can see it can be written with 2 terms, 3 terms, 1 term. So the maximum number of terms a quadratic polynomial will have is 3. A cubic polynomial is written as ax cube plus bx square plus cx plus d, again a not equal to 0, and other terms can be 0. You can write some examples for this. 4x to the power 3. With just one term you can write down the cubic polynomial, or y cube minus 1, or it can have 3 terms: t square minus t cube plus 1. Maximum number of terms a cubic polynomial will have is 4. Try to categorize the polynomial given. It has 3 terms, so it is a trinomial, and the highest power is 2, therefore it is quadratic because the degree is 2. The coefficient of x square is 4, coefficient of x is 7. What about minus 2? Minus 2 is a constant. But we can say that minus 2 is the coefficient of x to the power 0. Remember, x to the power 0 is 1. So minus 2 can be the coefficient of x to the power 0, because minus 2 into 1 becomes minus 2. So this number minus 2 is also a polynomial, which is called as constant polynomial. So all constant numbers like root 5, 5 upon 6 are called as constant polynomials. What about the degree of a constant polynomial? A constant polynomial, as I said, can be written as constant multiplied by x to the power 0. So in this example, this constant polynomial can be written as minus 2x to the power 0. So the highest power of the variable is 0. Therefore, the degree of a constant polynomial will always be 0. A constant polynomial will always have degree 0. What about the number 0? Is it a polynomial? Yes. 0 is also a polynomial, which is called as 0 polynomial, because 0 can be written as 0 times x to the power 0, which is 0 into 1, which is 0. So if we can write 0 in this form, it is a polynomial. But what about the degree of the 0 polynomial? the degree of 0 polynomial is not defined. So you will have no question asking you about the degree of 0 polynomial. So polynomials can be categorized based on the number of terms as monomial, binomial, trinomial, so we know the terms related to polynomials up to 3 terms. Can polynomials have more terms? Yes, polynomials can have any number of terms. But it is not infinite. So a polynomial can have more than 3 terms, but the number of terms should be finite. So we can write a polynomial x to the power 100 plus x to the power 99 plus x to the power 98, so on, x plus 1 is a polynomial that has 101 terms, and degree of this polynomial is 100 because that is the highest power. Consider this polynomial 5x square minus 3x plus 7. Let's take x to be 1. If we replace x in this polynomial, then we will get p of 1 equal to 5 1 square minus 3 times 1 plus 7. This is equal to 5 minus 3 plus 7, which is equal to 9. So this number 9 is the value of this polynomial p of x at x equal to 1. This is how we write value of p of x is equal to 9 at x equal to 1. What this means is, if we substitute in this polynomial value of x as 1 and then calculate this sum, then the value of polynomial is 9. So for the same polynomial p of x equal to 5x square minus 3x plus 7, let's find its value at x equal to minus 2. So p of minus 2 is equal to 5 times minus 2 square minus 3 times minus 2 plus 7. Now calculate this expression. This is 5 times 4, that is 20, minus 3 into minus 2 will give you plus 6 plus 7, that is 33. So value of this polynomial p of x is 33 at x equal to minus 2. With this, we come to the end of this video class. Now you are equipped with the knowledge to do this assignment. Exercise 2.1, question number 1, 2, 3, 4 and 5 neatly in your notebook. I will see you in the next class with a new concept. Until then, goodbye.